Cool. All right. So your Kernel and You. This has been chosen kind of on purpose. So I'd like to start by what you will learn, right? What kind of things can you learn out of this? The most important is you can use memes for everything. It doesn't matter if it's a business presentation or in front of a president of a country, it's fine. You get a good oversight of how cgroups work, namespaces in the kernel as well, which are very important. Maybe something else, I don't know. I'll try to throw information at you in whatever holds. So who the hell am I? My name is Marc. I'm a pesky Catalan living in London for 10 years. I organize London DevOps, so different meetup than the ones that DOMS organizes, which is like all of them. I organize also DevSecOps Days London, which happens once a year. I co-organize DevOps Exchange Barcelona, so if you're around there, make sure that you visit us. I've been working and doing DevOps in a lot of places, Rackspace, Trainline, Canonical, Acer's DevOps Group, and I've been doing DevOps for way too long. I might need a coffee by now. And I like to swear a lot, so if I swear during this presentation, I hope there's the proper beeping on YouTube. So right now I work for a nationwide building society. It's a financial institution. Nice, thank you. I'm a happy customer. Don't leave us. So just in case you wouldn't guess, we're hiring in London. So if you're interested in working Kubernetes, doing cool stuff, I'm being, I would say, being compliant with all the fiduciary duties of a financial institution, then please come join us. I said I also organize London DevOps and DevOps Exchange Barcelona, also known as Doxalona. These are not run by DOM yet. But not yet. But if you go there and you find them not to the level of quality that you're used to, please use the hashtag not run by DOM, and we'll do our best to get to the standards that you're used to. Yeah? Nice. So do you have time to? It's important because we want to know that we're doing things right. Yeah? Cool. So your Kernel and You. So sometimes you wonder what happens in your kernel. Do you feel funny? You don't really understand what's happening inside there, but you have the feeling that something's happening. Nobody explained that to you. And it's like, you ask your parents and they go, oh, no, I'm not speaking about this now. You talk about it, right? So mainly because I said Google can replace sex education, I'm going to try to give you everything you need to know about the kernel, so there's one thing less in your life that you don't know about. So the first thing is like containers are not new. Everybody has heard of Tupperware, but besides that, cheap joke, I know. Besides that, I would say the first attempt to containers was it was more or less remarkable was in Unix. Almost when Unix started in Unix version 7, it was known as chroot. It was very hacky, very bad. You could get out of it so easy. It wasn't even any kind of container, but it was mainly a container for a file system. And then on top of that, you could run your processes that had all the same access to the kernel, CPU, et cetera, et cetera. Then in the year 2000, FreeBSD started using FreeBSD jails. That was a lot better. There was still, I would say, a lot of constraints about trying to handle CPU and all of that. So you could get containers that would use all your CPU. So it was a bit wild. And also it was FreeBSD. So seriously, who here uses FreeBSD? Yeah, one, maybe two. Yeah, well done, mate. So yeah, it didn't have a lot of traction on that. Then after that, in 2004, Solaris did what is called the Solaris containers. It was the first one that was real I/O, memory, and CPU-ish kind of containerization. They were very good, but Solaris was a commercial product. They were talking about making it open source, but then this happened. So it didn't go to open source. And then in 2006, then based on all of that, Linux had the first implementation of cgroups, and Then in 2016, 10 years after, cgroups version 2 was deemed not risky and not experimental in the kernel, and was admitted into the normal branch. So cgroups, it was implemented by 2 guys from Google. If I had my presentation notes, I would tell you exactly who. But let's say there were 2 guys at Google. So they did that because they were patching the version of Linux that they called Google Linux based on Ubuntu, who was based on Debian. So we kind of had something to do with that under NDA. It was based on this thing called Borg. I'm sure all of you know Borg by now. I would say, considering that Google doesn't do evil, it wasn't the greatest name ever. But nonetheless, Borg looks something like this, just for reference. I'm sure everybody finds this familiar if you've done Kubernetes at least 3 seconds in your life. So with cgroups implemented, then the community started working and acting on that. And the first attempt to do a framework that used cgroups well was called LXC. LXC is just literally Linux containers. I mean, great idea, greatest name ever. Has anybody here tried to use LXC? Yeah, some brave souls. Good. So using LXC more or less looks like this. I just found this as a random screenshot today. It's pretty much, it really feels as painful as that. You had to mount the file system yourself. You had to start the container. Then you had to do a console that didn't even have proper TTY, so you wouldn't even have proper escape characters. So whenever you're using that, it's like, I'm very confused. This is very complex. I'm just trying to run a single application, and if I have to do 2 of these, I'm going to cry. But thankfully, some years after, then Docker came on. Hey, yay, Docker, yay. And it made things a lot easier. So running a container was as easy as this. So this was like, yes, finally, someone that makes something complex easy. So I really felt like this. It's like, this is so awesome. It needs to happen more, yeah? So that's the history part of this. So if you think about the technical part, and this is where you will learn something. So you need to start thinking about what you need in a kernel to do a container, right? So it's a bit like a shopping list. Like I need of this, a bit of that, a bit of lemon pledge here and there. So if you look at what you need in a kernel, let's say that you need an isolated file system, right? You want to write into your container. You don't want to start writing in other people's containers. You don't want to start writing in the host or anything like that, because this is your container. Everything should be there, yeah? You need isolated memory. You don't want to start reading pages of someone else or some other critical information that is on the memory of the machine. And you need some isolated CPU, right? You need to make more or less sure that you have enough CPU cycles to run your application, but at the same time, controlled in a way that it doesn't consume the whole host and you leave everybody else shouting full CPU. But then on top of that, you need isolated users as well, right? You might want to create your users inside that container that they shouldn't leak into the host. You also want your isolated network. You don't want to share your network with anybody else, because otherwise you would just be running TCP/dump, feeling like a very good, amazing hacker, because you're just reading everything from everyone. You want resource limitation on disk, users, network, etc. And you want some accounting as well. You want to make sure that not only that you're consuming, but what you're consuming, ensuring that everybody's accounted for. So all of these things exist at some level in the kernel, and they're called namespaces. So the problem with that name, I would say the community in general is very bad at doing names. And the problem with this name in special is that we use namespaces everywhere. So it becomes kind of meta at this point. It's like namespace of the namespace. Which namespace? The kernel namespace, the Kubernetes namespace. You're talking about the namespace in the host. What are the names that you're talking about, right? But this is just like really said, kernel namespaces. So there's 6 of them that are fully implemented right now. The first one is the mount namespace. The mount namespace, the only thing it does is that it does chroot, but a lot better. So you can mount a part of the file system or another file system inside a jail, And there's no way that you can escape that. In chroot, you could escape in many ways. In this one, it's fairly secure because it's all bounded by the kernel. You have UTS, that the only thing it does, and I know this sounds stupid, but it has a very good reason. It decouples the host name and the FQDN of the host. So you don't end up with all your containers named exactly as your host. And you want to give them names. I know cattle, not sheep, but you want to give them names nonetheless because you want to know who you're killing. But they said you shouldn't have the same name everywhere. And that, in kernel terms, is very difficult because Unix in general, the host name and the FQDN is essential to the networking system. So that's why we needed this namespace. Then, of course, an IPC namespace, because which modern kernel doesn't do IPC calls and POSIX calls and all of these. So you need to isolate them as well to ensure that they're secure. A process ID namespace, because you always know that your init or your first or systemd now, God forgive us, systemd, your first process will be always process number 1. It should be also process number 1 inside your container, because there's a lot of things that depend on that, and there's, I would say, a lot of hard-coded software that expects process number 1 to be your init or your systemd in this case. And of course, you don't want to be running millions of containers inside a host and running out of the process ID allocation table, which stupidly only goes to 64K. So because that was enough for everyone back then. You have your user namespace, and this is mainly you can have 2 users named exactly the same, one inside the container, one inside the host, and they're actually different users. And you want to do that because, again, there's a lot of things that are very attached and connected to the names, to the usernames, like, for example, the Nginx user or the Apache user and things like that, in order to run web servers. And you have the cgroup namespace. So, and this is, for me, the most interesting and important one. So I won't speak a lot about it now because I'm going to go a bit more in depth about it. But then you have 2 extra namespaces, which are the time namespace and the syslog namespace. They are still in implementation. When Linus Torvalds stops swearing at all the patches that are put for these, maybe it will go all the way to stable. So there will be, as I said, to keep different time inside the machine, so you don't depend on the internal time clock of the kernel, and to be able to have different syslog channels as well, which is very useful because right now you need things, as I said, like Docker or Kubernetes or Prometheus or things like that in order to be able to channel all those syslogs and be able to segment them in some way. And these, per se, if you look at them, they are very powerful. But the thing that is incredibly powerful about them is that you can connect them in any way you want. They are completely transposable. So, for example, one thing that Kubernetes does is that it doesn't use the mount namespace for networking. It uses the host networking, but then it connects all the rest of the namespaces to the host networking. And it does that on purpose in order to make networking slightly less complicated. But you can do that. You can put one on top of the other. You can connect one to the other. You can choose which ones that you want to activate. So at the end of the day, that feels like a big spiral, but it's very useful. It's very powerful, and you can do a lot of things on that. So what is cgroups? Cgroups are mainly for controlling and accounting. So it's the thing that stops your container from eating all the memory, eating all the CPU, eating all your disk throughput, all your network, and more things. They keep that. They give an idea of the container of how much it can use. It limits that, and in the worst case scenario, is capable of killing containers that are broke. So in cgroups version 1, that was implemented in 2006, you have 12 controllers. So there's 12 different kinds of control that you can control through the kernel and declare. And you have isolation per thread. So the minimum unit was a thread of processes. Right? So you cannot go further down than that. You cannot go further down than the thread. So individual processes, you cannot track them. When we implemented this in Ubuntu, I was responsible for part of that. There were 2 things that were incredibly funny and frustrating at the same time. One of them is the kernel out-of-memory killer. It didn't know anything about any of the namespaces. So the kernel out-of-memory killer, what it does is that it looks at the most active process, the most rampant memory user, and it kills it with fire, literally. So the problem with that is that you would have a container running and suddenly one of your processes would be dead, and you didn't know why. Because the kernel out-of-memory killer would just go in, kill it with fire, and be happy and keep going on. The other problem that we had is that the initial integration of cgroups was very leaky, and very leaky up to the point that you would see process IDs duplicated inside your host from different containers, and you didn't really understand why, and it was a complete mess. When you try to solve that, most of the time you would get a very nice kernel dump, and the system would stop working. So I said, if anybody suffered through that, I can only apologize. I suffered through it as well. But I would say with time, things got better. We fixed the bugs. Things were starting to work better. Linus Torvalds, with his usual amount of swearing, fixed most of the things and accepted most of the patches. And they went to the kernel, backported by all the distributions. The kernel out-of-memory killer started to understand what a container was, what the cgroup namespace was, and it would kill the whole cgroup namespace. So instead of killing processes inside your cgroup, it would just kill your whole container, which is a lot more refreshing. And then on top of that, there were a lot of the problems that we had with the leakage that were solved as well. So complete isolation was a thing in less than a year, which was very good. So if you want to look like I want to look like a real kernel hacker and start looking at those controls for cgroups, you can easily go to the system FS, which is just a representation of the kernel and all the variables it has. So if you go to /c/fs/cgroup and do an ls, you will see all the controls for cgroup. You can actually touch them through that. I would not recommend it unless you want to kill your machine. Then please go ahead and do it. It's fun. But yeah, as you can see, if you can count besides the soft links, there's actually 13 here because they're systemd. Hooray, systemd getting everywhere. I really like it. So that's mainly said cgroups. It just controls all these different things. You can adjust them per container. You can have full isolation. You can have full control of the CPU, memory, disk, IO, network, etc., etc. You can create different networking interfaces for each one of your containers in a complete kernel isolated way. The thing is that, as with any code, it gets old, it has all these limitations, and then patching on top of patching on top of patching, it starts to look a little bit like that Volkswagen from the 60s that looked very nice when you bought it, but nowadays you only hope that it actually works. So there was a full rewrite that started in 2014, and then in 2016 it was deemed non-experimental, so it went to the main kernel. It does full isolation per process. So the thing that you can actually do is for example, the Docker and Docker thing, but you can actually do that with the kernel. You can get a process inside a container and make another container out of that process, which for some reasons is useful, like for example, security isolation and things like that. You have better use of the namespaces. So far in cgroups version 2, there's 3 controls implemented that directly affect the namespaces. And you have better atomicity of CPU usage as well. So if you want to read a bit more in depth, you can have a look at that article. It is written by the maintainer of cgroups in the kernel, and it explains exactly what was the driver of the rewrite and what kind of things are they doing with that. The thing is that with cgroups version 2, as with anything, it just started, as I said, it's just 3 years old, which for most startups is like several rounds of funding, but for the kernel, it's very quick. 3 years is nothing. So it's still not enabled by default in most distributions. So in most distributions, we will have still cgroups version 1. So almost sure that 99% of the distributions you use only use cgroups version 1 so far. The good thing is that they knew about this. They knew about everything that was already running in version 1. And they made it in a way that you can actually automatically replace one of the controls of version 1 with the version 2 control, and you can have all the rest still running in version 1. So you can choose and pick which ones that you want from each version. So if you want to try it, for any reason, say you want to play with it, like I did just today in my Vagrant machine, you can actually mount it, use it, the mount namespace, and then it has a representation. By just doing that, the mount-t cgroup2, it has a representation of cgroup2. It's activated on the kernel, so then you can start touching all the different flags. So the cgroup dot whatever name, and we start playing with it. So if you want to, and if you want to set to get deeper into the kernel and all of these, please do. It's very fun. My recommendation, first, don't do it in production, of course. And second, if you do it in an isolated machine that you know you can kill, because touching the kernel is always fun, but it will make your machine explode in very imaginary ways. So just make sure that you do that in a safe way. I said safety above everything else, right? Especially, I said, in education on the kernel, be safe. So basically, once this being said, in conclusion, cgroups are awesome. They are the ones that enable everything that creates containers. It builds on top of namespaces, which I said are not related to containers per se, but are the ones that enabled modern containers to work. Version 1 is still the most one used. Most problems are fixed. Hooray. That's good news. You can use compostable superpowers to be able to connect namespaces in different ways and be creative. And I hate bullet lists, so I try not to use them too much. So yeah, so any questions you may have. If you want to follow me on Twitter, I'm just 50 followers behind Dom. So I'm trying really hard to pass her because she's a big deal and I have to as well. So if you follow me, I'll pay you a beer afterwards, but I didn't say this.
Rounds on Mark. Anybody questions? Any questions, anybody? Are you going to make me some more exercise?
Yeah, one.
Oh, yes, okay. All right.
That's a good for you.
Kidding.
Great talk, Mark.
Thank you.
So, as with cgroups v1, the maturity level there allowed us to do a lot of stuff with containers and containerization. What do you see the future of version 2? Do you have a mystic ball that you can dig out some information about that?
That's a very good question. I wish I had that mystic ball. First of all, I would say the first thing is get parity of features with version 1. Version 1, I said, it was written 10 years ago, so there's a lot of things that have been patched, repatched, and overpatched. You still do have some process leakage from time to time. It's not the usual thing, but for example, Kubernetes has some killing mechanism when it detects that. So sometimes it kills your container because it leaks. So that's not 100% there. So with cgroups version 2, it was rewritten in a way that to ensure that all these things, all these problems in the past didn't happen. But of course, with any software rewrite, we'll just have newer and most awesome problems to deal with. So I said, I think it's just a question of getting parity of features, and then after that, see what we can do.
Thank you.
Cool. So people in the back, like in the back. Do you have any questions? I can run to you and hand you the microphone if you want. I'm seeing shaking heads. Yeah. Anyone up here? Yeah. Okay. Cool.
Yeah. If you're too shy to ask a question and you want to ask afterwards, I'll be the guy with the blue polo.
Thank you very much. In your very elegant presentation, you failed to mention LXD, the virtualization aspect of LFC.
Yes.
And you failed to mention the fact that the lambda serverless functions
yes.
Run exclusively on Linux containers.
Yeah.
There must be something AWS and the other cloud providers must have seen in the strength of the kernel, especially after 2.6, for them to run lambda functions exclusively on Linux containers.
Yeah. So I didn't mention LXD on purpose. And I didn't because it was written by a friend of mine that I really, really like, and I don't want to talk bad about my friend's software. So I did that on purpose. LXD is fine, but that's what I say.
This is being recorded, thank you. Any other questions? Anyone down there? I'm just casually strolling back. No questions? Yes, questions? What? No, yes, no?
Okay.
Oh, there you go, sorry.
Yep. Again, very nice presentation. Quick question around like, how do you like detect memory leak? Is it only by trial and error, or do you have like more formal method to do it?
I can tell you the one that comes out of my imagination, but in reality, the way that we did that is that I would say nowadays it's difficult because mostly the errors that we have in namespaces for memory and cgroups for the accountancy of memory will be race conditions. And a race condition against the kernel, it's very hard because 99% of the time the kernel wins. But it can still happen. That's when the rabbit called the kernel out of memory killer will come in and kill your kernel, your container with fire. It happens. It still happens. It's a lot more contained because I said, considering that most of the time it's race conditions that will cause that, the kernel is faster than you just because you have to go through the kernel.
Cool. Anyone else? Going once? Yes.
There you go.
In version 1, it was like say like isolation per 12 containers in version 1, and version 2 is like per process.
Yeah.
But at last you mentioned like version 1 is most used than version 2.
Correct.
So what's the functionalities between version 1 and version 2?
I said version 2 is just started. It was deemed non-experimental 3 years ago in the kernel. I said that for kernel time is yesterday. So there's a lot of implementations that are using directly kernel flags through kernfs that go straight to version 1, including Docker and Kubernetes and any other kind of container driver. So in order to adopt version 2, I said you first need parity of options. Version 2 only has 3 controllers so far. Whenever, I'm sure that, I said, Docker and Rocket and all these container engines are waiting for version 2 to have parity of features with version 1, and then they will start migrating towards that. But also you have to consider the life cycle of distros. So for example, I cannot speak for Red Hat because I haven't worked at Red Hat, but I can speak for Ubuntu. In Ubuntu, the LTS releases are 5 years old, so you have support for 5 years. What that means is that you will still have servers that are in support, so they will get all the kernel patches backported and all the security patches for 5 years since the release. I said kernel space is long, so it will take several years for version 2 to be the mainstream. So I said it just started 3 years ago. I can easily see that it will take at least 3 or 4 more years to be the main version.
Cool. Oops. Oh.
You okay?
No alcohol, promise. Any other questions?
Cool. Very important. Follow me on Twitter. I need to beat them.
I mean, I can look up the current tally. It's not a competition. But you're on 1779, and I am on 1874. So get following, people. All right. Any other questions? No. Cool. Give a very big round of applause for Marc.
Thank you.